So this is the Python demonstration part. So I have 3 files. Each file is for each machine learnings. So this currently I open is for K nearest neighbor KNN, and then I have ENN, which is for artificial neural network, and then lastly is I have a random forest. So however, half of the codes is actually the same, which is start from importing libraries and then reading the data for the pivot table, and then for distribution amount, and then for feature engineering, and then for tokenization, balancing, preprocessing, one hot encoding, and then split and standardize, and then dropping unnecessary columns is actually the same. Also this one, which is model building, is the same because there is nothing related for a certain machine learning parts. So this is what we call a general part. So I will start explaining for ANN first. So as we can see here, the first part is where we put basic libraries. As I mentioned, I import Panda, NumPy, Seaborn, Matplotlib. So each libraries have its own use. So example, Panda is used for data manipulation, NumPy is for numerical computation, for Seaborn and Matplotlib is for creating static visualization. However, for Plotly is used for creating interactive visualization. And then some of preprocessing libraries. We have standard scaler also is used for standardize by removing the mean and scaling to unit variance. So we have scikit-learn. Scikit-learn is basically libraries for various machine learning model. So and then we have metric libraries for accuracy, precision, recall, and coefficient metrics. So we have libraries for warnings also. So this is the reading the data part where we want to call an Excel file or any file of the data set. So we give a parameter such as here is PaySim. So and then read the raw data file. And then PaySim.head is for looking at the data, and then we have PaySim.info to display the data types. So we can see here is the data type. So here we want to look at the data, so we have step, and then we have type, payment, transfer, cash out, and then we have amount, and then we have the origin, and then the old balance for the origin, new balance of the origin, name destination, old balance destination, new balance destination, and then is fraud or is flat fraud. Yeah. So we have 3 pivot table as I mentioned also. So this pivot table is to show whether it's flag fraud or is fraud. Yeah, so this is the sum part and this is the standard deviation part. So and then I choose the color orange. It's actually a gradient color of orange. And then we have pivot table here. Another pivot table I mean, so here is pivot table for the amount of new balance origin and old balance origin. So this is all for some for some, and the color here is purple. And then we have another version of pivot table which is in the color white. This is one to show the sum amount of new balance destination and old balance destination. And then we move into the distribution amount using box plot. So this box plot is to show the maximum, the minimum, and the median of the data set. So we can show here it is an interactive graph. So maximum here is 10 million, and then we have upper fence which is 457,000 amount, and then we have quarter 3, and then we have median, we have quarter 1, lower fence, and then minimum of the amount. And then we move into the feature engineering part. This is to telling the balance and calculate the difference between the new and old balance of both the sender and receiver accounts for each transaction. So if the amount debited from the sender match the amount credited to the receiver, if not, it reflects as a deviation. So yeah, so we have origin difference and destination difference. So this is to indicate whether there's a deviation for the sender and receiver respectively. So and then drops temporary columns. So this is the coding which is different for the balance, and then from sender balance to receiver balance. And then we move into the search indicator. So it creates a new column, search, which is set to 1 if the transaction amount exceeds a certain threshold. So in this case, if more than 450,000, if otherwise it is set to 0. And then for frequency indicator, it calculates the frequency of transaction for each receiver, which is name destination, and creates a new column, frequent destination, set to 1 if the receiver has received transaction from more than 20 different sender. If otherwise, again, it is set to 0. So the temporary column is frequent destination. So and then we tracking the receiver as merchant or not. So if one, it means that the receiver name start with M. So M is indicated as merchant, otherwise it is set to 0. So and then we move into applying balance different function. And then so here is the destination difference, search indicator, and then the frequency destination. After that, we do the pre-processing data. We want to have a balanced data, as I mentioned before this. So the first pie chart that we receive is 99.8% over 0.2%, as we can see here. So not fraud is 99.8%, while fraud is just 0.2%, which is quite distant. Hence, we are doing we did pre-processing by balance the target. We want it to have 50-50. So as we can see here, now it is balanced. We have 49,000 and 49,000 cases, not fraud and fraud. Yeah. And then we do one hot encoding where it is changed such as cash or debit from the character type into a binary type, and then drop the character type. Yeah, that is for one hot encoding. So and then we move into split and standardize, where splitting the dependent and independent variable, and then we do train and test split, which is 0.7 over 0.3. 0.7 is for train and 0.3 is for testing. So we use here is scalar, standard scalar for X-train. Yeah. And then we move into tokenization, where we token the name origin and then name destination. After we change from character into a token, and then we put some pad sequences, and then after that we drop again the unnecessary columns. And then we move into the model building, so where we import lots of libraries from scikit-learn, and then here we do the cross validation as I mentioned before this, using 10 folds, and then after run this part we can get the accuracy score. So we can see here for logistic regression 0.96, decision tree test we get 0.97, KNN 0.98, SVC 0.97, and then knife Bayes we got 0.99, random forest we got 0.99 also, and for ANN is 0.96. So why I didn't choose the highest tree. It is because I don't want to choose the perfect one. I choose the machine learning that I want to learn about. Yeah, hence I'm choosing the random forest, ANN and KNN. So we can see here random forest is also almost perfect, with 0.99, and then for ANN is 0.96, and then KNN also almost perfect with 0.98, even though not the top highest. And then we move into the modeling part. So this is 5 for ANN. So we start with tenfold to the ANN model. We create the ANN model and then perform grid search with cross validation, and then feed the model into the training data, and then print the estimator found, the best estimator found. And then after that, we calculate the confusion matrix. So we plot the confusion matrix. So here we get the plotting for confusion matrix. So as we can see here, the top one is the without normalization, and the bottom one is normalized. So I want to show how to read this confusion matrix. So for the, let's say for the true label, which is it is not fraud, however it is predicted as not fraud, which is true positive. Curly, which is correctly not fraud, here we get is 7004, which is the normalized percentage is 0.47. And then for positive, which is not fraud but is predicted as fraud. So incorrectly not fraud is 7,898. The percentage is 0.53, and then this is the main part here, which is the false negative. It is 0, which is good. So incorrectly fraud is not happen here, 0. And then the last part is true negative, which is correctly fraud is can detect almost 15,000. And then here is the printed classification report. We can see here the precision, recall, F1 score. So we can see is the micro average here that I took and put inside the table. So we move into KNN. We straight to the confusion matrix. So now we start from here where we define the parameter grid for KNN, and then initialize the KNN model, and then we set up the grid search for cross validation, and then print the best estimator also. So this is the part we want to plot the confusion matrix. So for the KNN part, for the KNN part, so the true positive is 6,271. For the false positive, we get is 8,631, and then the fraud is still the same 0, and the true negative, which is correctly fraud, is also the same, which is 15,038. So this is the normalized confusion matrix, and this one is the classification report. And then the last machine learning model is RF, which is random forest. So this is the confusion matrix. Before that, it is also the same where we do the grid search cross validation, and then print the best estimator, and then we plot the confusion matrix. So the true positive is 7,302, and then the false positive is 7,600, and then still the false negative, which is incorrectly fraud, is 0, which is good also. And then so the fraud, correctly fraud is same through all three machine learning models, which is 15,038. So this is the normalized conversion matrix, which is the percentage of the same as the top conversion matrix. So here is the classification matrix report for this machine learning, which is RF. So I think that's all for this Jupyter notebook part. Thank you very much for watching this demonstration. Bye!